Hi, so I want to talk about a tool that's not completely necessary for SLAM, but I'm going to use it, and it's just like a nice tool to use in general. I'm going to use it for rendering actually, also not quite idiomatically, but yeah, still it's worth knowing. So it comes from neural networks world, and what it does, it just speeds up operations that rely on like matrix multiplications or something. So here's an example function, and we're going to speed it up. So it takes matrix A, matrix B. They are just like two-dimensional matrices or arrays. We multiply those. We take sigmoid, which is, so sigmoid looks something like, no, not sigmoid social, sigmoid function. Sigmoid function looks like this, right? Just like maps from 0 to 1, from minus infinity to infinity, it maps to 0, 1, just squishes it. So we take the product of those matrices, we sigmoid it, and then max it. So take a max of this array. And so yeah, it works. It's 1. I'm kind of not surprised that it's near 1, because it's just like a lot of random stuff. We'll have all sorts of, so yeah, anyway, yeah, let me just not get too much into ways of explaining every single thing. So if I time this operation with Jupyter Magic, let's see what we get. So something like this, 1.58. And again, 1469. All right, and then we take the following steps. We do import jax numpy as jnp, change this to j, and then what we will also do is we'll do from jax import just in time, and we'll decorate this function with just in time. And right, we're going to copy same exact thing and interpret it, and we'll see how it goes. Yeah, so we get like what, 30% speed up, 40% speed up with just like importing a different package. Let's execute it one more time just to see what happens. Yeah, so even better speed up, like approaching maybe 50% right now. So what happens is as follows. So jax takes this function, it traces the operations we did to matrix A and matrix B, and then it expresses it like in intermediate language. This language is called XLA. Excuse me. And this intermediate language, it can be, sorry, that's all in Polish, but of course you can have it in English. And then there's like so jax expresses the computation in XLA, and then this XLA is compiled down to actual binary. You could think via C++, and this C++ is written in an optimized way. So instead of, for example, remembering the whole thing, the whole product over here, it can only just iterate over the array and only remember the max, because it already knows that it's going to only remember the max. So why hold on to this whole memory, right? So that's like an example optimization it could do, right? So instead of doing, let me just write like a pseudocode just to be super explicit. So something like this, right? So partial ij equals sigmoid of product ij, right? Instead of doing this and then having to do again a for loop, and then so m is, I don't know, minus inf, and then we see if partial is greater than max, instead of doing something like this, right, we could optimizer can, so the compiler can optimize like this, like if t is greater than m, then something like this, and then like that we skip a whole one big loop, something to this tune. But like all of this doesn't come for free, so there's a whole lot of caveats that I could mention. I just want to mention a couple of them. So first caveat is in JAX, if we have, so if we have normal numpy array, so let's say zeros, right, and then we do like, I don't know, 100 100 or 10 10, right? So this is all good and nice, and then we can just print it, okay, and then we can do like a 3 4 is equal to 7, and then we can do 1 1 is equal to 4, right? No problem, this all works. Here's our 4, here's our 8. But if we were to do JNP, JAX, then we get blah, 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 object array does not support item assignments. JAX array are immutable. Instead of this, use this. And this add thing, it copies the whole array, because JAX array are immutable. So that's a major thing, because it's a thing. So it's pretty popular in VSLAM to try to modify, so both in VSLAM and rendering, it's very popular to try to modify some array in place and sort of treat the frame as state and just keep writing to it, but JAX makes it impossible. So JAX is mostly focused on neural networks, and in neural networks you don't really need this mutability most of the time, and by making the arrays immutable you actually avoid many bugs, so it's sort of a feature. So that's one thing. And another thing is like this matrix operation, right? So when we just in time it, so at least as of my latest knowledge, so I last went deeper into JAX like a couple of months ago, maybe 2 or 3 months ago, and then back when I was learning it, it was the case that, so if this is an array of shape 100 100, right, and then it's like of type, let's say, float, and then our yes, like this. All right, so if that's our function, right, doesn't matter what it returns, and our arrays are of shape 100 100, this is like my pseudo notation, so this is like shape 100 100, right? If the array input arrays are of shape 100 100, then this just in time, it will compile a function that always assumes this 100 100. And if we pass some other arguments, either of other d type or of other shape, it will have to just in time it second time. So if you keep passing to this array arguments of different shapes, you will have this weird jumps in performance. So when you pass an argument that has already been seen, which shape has been already seen by JAX, it will be fast because it will be already compiled. And then on the contrary, if you pass some new shape, you will have to wait for it to compile. And that's a known limitation and something to keep in mind. So yeah, that's JAX. And we're going to use it for rendering.